Dear all, in this session, we will learn how to conduct slope analysis in QGIS. After completing this session, we will gain a foundational understanding of slope analysis. The module consists of three steps: data acquisition, analytical operation, and analytical results. The technical route is displayed on the screen. Briefly, we must first extract the necessary raw data, then analyze it to obtain the initial results and visualize them as final results. Step 1 is data acquisition. Digital elevation model, or DEM data, is the most widely used type of data. According to Wikipedia, a DEM is a representation of terrain height information. DEMs are particularly useful and commonly used in topographic analysis, such as terrain and hydrological analysis. The resolution of a DEM is its fundamental information. The resolution of a DEM refers to the spatial detail represented by each grid cell. It is commonly expressed in meters. It is generally classified into horizontal resolution, ground distance covered by each raster cell, e.g., 5 meters, 10 meters, 30 meters, etc., and vertical resolution, the precision of elevation values, e.g., 0.1 meters or 1 meter. The image on the screen illustrates the differences in various resolutions. The common classification of DEM resolution used in practice and research is displayed on the screen. In general, global scales always utilize resolutions greater than 100 meters. Regional and urban scales typically use resolutions between 10 and 100 meters, and site scales typically use resolutions between 1 and 10 meters. SRTM, Aster GDM, at ALOS World 3D, Copernicus DM, TandemX, and LiDAR-based DEMs are some of the popular DEM datasets. The screen displays their details. In this case, we will use Aster GDEM due to its availability and convenience. To collect the data, we will introduce a website called Geospatial Data Cloud. Of course, there are other websites that can provide the data we need, but this is the free and easily accessible one. The site link has been displayed on the screen. Please be aware that we will need to register the first time we use the site. After entering the site, we'll need to use the advanced search section. First, we must select the Aster GDEM dataset with 30-meter resolution. Next, we need to set the location. In this case, we use the administrative location to pinpoint Shatan in Hong Kong. Of course, we can decide the place by drawing a rectangle or a free shape. After choosing a place, click the search button. The screen will then display the data covering our location. To download the data, we may simply click the down arrow. Then, we need to download an administrative boundary document. We utilize the Ali Cloud platform in this case, and the screen displays the website link. However, if we already have a vector boundary file, we can skip this procedure. After entering the website, simply zoom in to find Hong Kong. Pinpoint the Shatan district, and its URL will display on the right. Simply select GeoJSON and copy the URL. Then we must go to a web page called MapShaper, where we can simply paste the URL, use the shortcut key Ctrl-V to view the boundary. Following that, we must export the border in shapefile format. Step 2 is analytical operation. First, we need to create a new project. Click New after selecting the Project button on the toolbar. We can now load the DEM data to the new project. We simply need to drag the image displayed in the browser frame to the layer frame. After that, place the mouse arrow on the targeted layer and click the right mouse button to access the properties to check the information. Pixel size and CRS are the key details to check. The former ensures resolution. The latter confirms the coordinate system, universal transverse Mercator zone, and projection. In our case, the coordinate system is WGS84, and the UTM zone is 49N. If we want to modify the display style, go to Symbology and select a preferred color style. Now, we must import the boundary file into the layer frame. We'll use it to trim the DEM data. Simply select the raster option, then extraction, and the click Clip Raster by Mask layer. The input layer is our DEM layer, and the mask is the boundary layer. Set all options and click Run. We now have DEM data with the boundary of the Shatan district. We must export it to make it a permanent file. Now, we will begin the analysis literally by opening the Slope tool in the Raster Terrain Analysis section of Processing Toolbox. After launching the tool, we have to set up the necessary options. The elevation layer must upload our clipped DEM data, and the default Xi factor is 1. Next, provide the saving path of the output. We now have the slope analysis result and need to visualize it. Put our mouse arrow on the slope layer, then click the button and select Properties. In the symbology session, we must specify the render type as paletted/unique values and select a preferred color ramp. The slope now has a contrasting visualization, with blue indicating the lower slope and red representing the higher slope. However, we are unable to extract direct useful information from the results. Thus, we must modify the display based on slope intervals. Similarly, enter the layer's properties. Change the render type to single-band pseudocolor and the mode to quantile. Thereafter, we must set the interpolation to discrete. Please note that the label precision represents the number after the decimal point. To modify the interval, place our mouse arrow on the value and click twice. We divide the classes into 6 classes: 0 degrees to 2 degrees, 2 degrees to 6 degrees, 6 degrees to 15 degrees, 15 degrees to 25 degrees, 25 degrees to 35 degrees, and more than 35 degrees. Thereafter, we can select our favorite color ramp. We now have a categorized slope with 6 classes. The slope categories are empirical. The table lists the differences and suggestions for each category. Flat terrain, 0 degrees to 2 degrees, and gentle slopes, 2 degrees to 6 degrees, are excellent for development. Mild slopes, 6 degrees to 15 degrees, and moderate slopes, 15 degrees to 25 degrees, can be developed through appropriate terrain engineering. Steep slopes, 25 degrees to 35 degrees, and very steep slopes, above 35 degrees, are not permitted for development and are best preserved. Of course, there are no absolutes. The data offered here are merely empirical recommendations. To export our results, we must first create a layout. Click Project and choose Layout Manager. Click the Create button and name the layout. Now we have a new layout. Click the Add Map button to load our results. If we like, we can also add a legend, a scale bar, and a north arrow by clicking their buttons respectively. After setting all options, we can export the map in the following formats: image, SVG, and PDF according to our needs. Thank you for watching. I hope this tutorial is helpful to you.